A block of mass m is attached to a lower end of a vertical spring. So this is the mass m which is attached to the lower end of a vertical spring. The spring is hung from a ceiling as a force constant value as k. Spring constant. The mass is released from rest with the spring initially unstretched. Okay. So this is the spring which is initially unstretched, which is like it's at its natural length L0. The maximum tension produced in the length of the spring will be. So now if when the mass now starts coming down, okay, so now when the mass starts coming down, what happens is, so it comes here. This is the equilibrium position where mg is equal to kx naught. So x naught is equal to mg by k. This is the equilibrium position, and then since it is acquired velocity, okay, since it is acquired velocity here, now it comes like it goes further down, and now the velocity will start decreasing. Okay, so in this region, in this zone, actually mg is greater than kx, and in this zone kx is greater than mg. So that's why here there is acceleration and here there is deceleration, and finally here the velocity is going to be 0. Initial also here the velocity was 0. So we will do conservation of energy. Okay, so at this level we have potential energy is equal to mg, and let us say it has come down till here, so therefore mg, we write it as mgx. Okay, kinetic energy is 0. Now here the potential energy is 0, kinetic energy is also 0. Now the potential energy which we are talking is actually gravitational potential energy in this case. Also let us talk about spring potential energy, which is again 0 here because the spring was at its natural length. There is no elongation or compression. Here the spring potential energy is half kx square. Now since the total energy of the system has to be constant, so therefore summing all of them, the total energy is mgx here. Here the total energy is half kx square. So therefore mgx should be equal to half kx square. Xx is gone, so therefore x is equal to 2mg by k. So therefore the stretch will be 2mg by k. Okay, so therefore B option is the correct one. We can also solve it by the SHM concept. Okay, so you see this is equilibrium, and this at this equilibrium, okay, about this only the spring is going to do the simple harmonic motion. Now since initially it was here, so therefore an equilibrium position is like k x naught is equal to mg. So therefore x naught is equal to mg by k. So that means we can consider it that the initial amplitude, okay, the distance from the mean position is mg by k. So therefore it's going to oscillate with the amplitude of mg by k. So therefore it is going to be further coming down to 2mg by k, which is mg by k plus mg by k. Thank you.